Okay, I want to talk about completing the square. Completing the square is a method that you can use in order to find the zeros of the function, okay? Zeros of the function are the x-intercepts in which y is 0, or the parts where the graph is going through the x-axis. Such as in this case, for example, look, if you have a graph like this, the x-intercepts, the points in which y is 0, can be points such as this, x1 and x2. If you want to find these points, there are different ways to find them. The first one is by factoring, which is GCF, special case FOIL. The second one is using the quadratic formula. And the last one is completing the square, okay? So today I want to talk about completing the square and how you can use this method in order to find the zeros of the functions, or in another way, the x-intercepts, or the points where the graph is going through the x-axis. In order to use the completing the square method, the first thing you need to do is that you have to check if everything is written in standard form, add up the like terms if there are any like terms that can be added, and write everything in standard form. So for example, I'm going to use an example here, this one, 9x squared minus 12x minus 2 is equal to 0. If this is given to you and you want to do it using completing the square, the very first thing you do is that you have to divide all the terms by whatever a is. So if this is the standard formula, the basic formula for a quadratic function, you have to make a 1. You have to make sure a is 1. And if not, divide all terms by a to make a 1. So here, a is 9. A is the coefficient of x squared. It's 9. So I'm going to divide all the terms by 9 so that a is going to be 1 here. So it's going to be x squared minus 12 and 9 are divisible by 3 both. And it's going to be negative 4 over 3x equals to, you have to isolate c in the second step, so I'm going to do it right away. So isolate c and move it to the other side. So it's going to be 2 over 9. So after this, you are supposed to complete the square, meaning you're supposed to make one of these special cases here, perfect square binomials. So either this or this. How can you make that? By adding b over 2 to the power of 2 to both sides. Which b? The b you created by making a 1. So you have to complete the square by adding b over 2 to the power of 2 to both sides of the equation. So I'm going to do that, and I'm going to add, what's the b here? It's 4 over 3. Since it's going to go to the power of 2, I don't care about the minus. It doesn't make any differences. 4 over 3 to the power of 2 is going to be 4 over 6. And you can simplify this to 2 over 3. And to the power of 2, it's going to be 4 over 9. So you're going to add 4 over 9 to both sides. And then find number 4 is going to be find the special case. Which ones? Either a plus b to the power of 2 or a minus b to the power of 2. So you're going to do that too. So it's going to be x times x 2 over 3 times 2 over 3. And if you check the 2ab part, meaning 2 times x times 2 over 3, it's going to be 4 over 3x, which is exactly what we have over there. So which special case is it going to be? It's going to be the second special case because of the minus over here. It's going to be x minus 2 over 3 to the power of 2 is equal to 2 plus 4. It's going to be 6 over 9. And I'm not going to simplify it because I'm supposed to take a radical here, and 9 is a perfect square number. So if I do that, I'm going to put myself in more trouble, of course, so I'm not going to do that. So now I have to get rid of the power of 2. How do I do that? I take a radical from both sides, and I don't forget about the plus and minus. Why do I put a plus and minus? Again, for the 100th times, x to the power of 2 is equal to 4, everyone, right? So it's either 2 to the power of 2 that can be 4, or negative 2 to the power of 2 that can be 4. So that's why when we take a radical here, we put a plus and minus so that we can actually include negative, the negative of that number as well. So let's get rid of this. Now I'm going to have the answer. So it's going to be x minus 2 over 3 is equal to plus minus radical 6 over 3, in which x is going to be plus minus radical 6, the minus is here, plus 2 over 3. You can leave your answer in the simplest radicand form like this, or you can use a calculator to find it in decimal form. However the question asks you to, or if it doesn't, you can just leave it however you want to. So, and the last step here, which I forgot to write, would be solve for x by taking a radical from both sides. And easily you can find your x.